Hi, welcome to Pencil College. In Chapter 7.1, we are looking at the midpoint of a line joining 2 points. And in this video, we'll be looking at some applications of the midpoint, distance, as well as the gradient formula. Okay, so let us look at example number 1a. The points A, B, and C are the vertices of a triangle. Calculate the length of AC and of BC and show that the triangle is an isosceles triangle. So the first thing you should do when you see this question, okay, is to draw out this simple sketch over here, as you can see. Then the next thing we want to realize, okay, is that in order to calculate the length of AC, we will be making use of the distance formula. Okay, so let me just highlight it in yellow over here. So let us look at the application of this distance formula. So the length of AC, so AC is equals to the square root, okay, so this long line over here, square root of the x coordinate of A, which is 6, minus the x coordinate of C, which is 5, squared, plus the y coordinate of A, which is -4, minus the y coordinate of C, which is 3 squared. Okay, working this out and simplifying further, I will arrive at 5 square root of 2. Okay, so in this example, I will not go too much in detail on the simplification. Okay, if you want to know how to simplify this further, please watch the video on surds. Okay, so this deals with your knowledge on surds. If you've forgotten, go ahead and review that video. Okay, so the next thing I want to do is to find the distance BC. Okay, so BC, similarly using the distance formula, I will first take the x coordinate of B. Okay, the x coordinate of B is -2 minus the x coordinate of C, which is 5, okay, squared, plus the y coordinate of B, which is 4, minus the y coordinate of C, which is 3, okay, squared. And similarly, after simplifying this, I will arrive at 5 square root of 2. Now, I want to show that the triangle is an isosceles triangle. Using our sketch over here, in order to show that the triangle is an isosceles triangle, I must show that the length BC should be equals to the length AC. Okay, so let's check if this is true. Why, yes, definitely. Okay, so because AC is the same as BC. Okay, so let me write out a mathematical statement for this. So since AC equals to BC, the triangle, or the triangle ABC, is an isosceles triangle. You got it. Triangle. And that's it. Okay, so I hope this is a simple example that shows you how to apply the distance formula. Okay, now let's move on to example 1b. The points A, B, and C are the vertices of a triangle. Find the coordinates of M, the midpoint of AB, and hence evaluate the area of the triangle. Okay, so M is the midpoint of AB. So where exactly is the midpoint of AB? Let me just probably mark it out on the sketch for you. So since the line AB is over here, okay, let me make it more obvious. So the midpoint should be probably somewhere around here, okay, around this region. So let us now make use of the midpoint formula. So midpoint formula is over here, and let me just find M. So M, which is the midpoint of AB, is given as the x coordinate of A, which is 6, plus the x coordinate of B, which is -2, divided by 2, comma, the y coordinate of A, which is -4, plus the y coordinate of B, which is 4, divided by 2. So working this out with the help of a calculator, I will just arrive at 2, 0. So therefore, M is a point along the x-axis, okay, and m should be right over here. So m is here. Okay, and the coordinates of m is 2, 0. Okay, so using this piece of information, I will want to find the area of the triangle. Now recall previously in example 1a, we proved that the triangle is an isosceles triangle, and therefore distance BC is equals to distance AC. Okay, and these two angles are also the same because it is an isosceles triangle. Therefore, okay, perhaps the sketch is not drawn to scale, but therefore to find the area of the triangle, I will have to take half times base times height. Okay, so if it's not too clear to everyone, let me just redraw the diagram and tilt the triangle a little bit so it's more obvious. So suppose C is here, B is here, and A is here. Then M is actually directly below C, okay, because M is the midpoint of AB and the triangle is an isosceles triangle. Therefore, the base that we're looking at is distance AB. Okay, so the area of triangle ABC is equals to half times base times height, which is equals to half, and the base is AB and the height should be CM. Okay, CM. So let us go ahead and find the distance AB. Okay, so how do we find distance AB? So we must make use of the distance formula. Okay, probably I'll use the distance formula, and let me just highlight it for you as well. So the distance formula is over here. Okay, and similarly, I will perform my substitution. So the x-coordinate of A is 6 minus the x-coordinate of B, which is -2 squared, plus the y-coordinate of A, which is -4, minus the y-coordinate of B, okay, squared. So this is my distance AB. Next, I will multiply this to my distance CM. Okay, so CM. So the x-coordinate of M minus the x-coordinate of C squared plus the y-coordinate of M minus the y-coordinate of C squared. Using my calculator to help me simplify this whole chunk of numbers over here, I will just arrive at 24 units squared. Okay, so I hope this wasn't too tough for you. Okay, and for more videos, please log on to pencilcollege.com. I'll see you in the next video. See ya!